Hello, this is Physics 103. This is on nuclear physics, and here we are going to learn about nuclear fission. So, nuclear fission is simply the splitting of the nucleus. So, say you have an unstable nucleus, uranium-235, and we have learned previously from nuclear reactions that if you bombard it with particles, it can undergo a nuclear reaction. So, suppose uranium-235 is bombarded by one neutron here. So, this neutron will combine into the nucleus, producing a very unstable nuclei, which is uranium-236. So, this uranium-236 will undergo nuclear fission, and it will split into two nuclei, which is barium-144 and krypton-89, and plus 3 neutrons. So this is one example of nuclear fission in uranium-236. So barium and krypton are not the only products that can be produced by nuclear fission of uranium-236. So sometimes it can also have another daughter nuclei. So as an example, it can also split into xenon 140 and strontium 38 plus 2 neutrons. So there's a lot of byproducts that can be made from the fission of uranium-236. So as we have learned previously, nuclear reactions release energy by the difference in masses, which we can compute using the equation E equals mc squared. So that is the reaction energy. So where does the reaction energy really come from? So if we look back into this graph, wherein in the y-axis we have the binding energy per nucleon and the mass number, and in the x-axis we have the mass number A. So we have initially uranium-236 around in this area, which is a very unstable nuclei. So its initial binding energy is about, let me check, about 7.6 mega electron volts. So sorry, not binding energy per nucleon. So if you have 236 nucleons in uranium-236, every nucleon will contain a binding energy of it will experience a binding energy with respect to other nucleons of 7.6 MeV. And after it underwent nuclear fission, so this is the final reaction. This is the initial or the before state. The binding energy per nucleon, or the energy experienced by each nucleon, will now be 8.5 MeV. So it's around here, 8.5 MeV. So subtracting 8.5 MeV minus 7.6, you will get about, this is about 0.9 MeV, and multiply it by 2 236 nucleons. So multiply this value by 236 nucleons, which is the number of nucleons inside the uranium atom. So you will get an energy release of approximately 200 MeV. So this 200 MeV is the expected increase in binding energy during the fission. So you have this amount of energy from this point to this point. So this is 0.9 MeV.